All right, hello, Math 111. I'm going to play around with polynomials a little bit and review for the test. So here I have a lovely cubic polynomial. And what I want to do is I want to try and find its zeros. So first thing I'm going to do is apply the rational root theorem. Rational root theorem says coefficients of the leading term, well, that's a 1x cubed, they go to give me my denominator. And coefficients of the last term, those go to give me my numerator. So what this tells me is my possible denominators. So again, these are possible rational roots. Possible rational roots or zeros. Numerators, well, I have a choice of 1. Factors of 22 are 1, or 2, or 11. Now when I put those together, I get the following possibilities. 1 over 1 is 1, 1 over 2 is 1/2, and 1 over 11 is 1 over 11. And any of those could be positive or negative. So I have 6 possibilities. And I wrote those backwards, didn't I? I hate when I do that. Got my numerators and denominators mixed up. So let's flip this shit. Sorry about that. Okay. And look at that. And we'll just move this stuff up here. Oh, come on. There you go. So those are my numerators. And these are my denominators. 1. All right, so trying that again. Make it plus or minus 1, 2, or 11. Still have 6 possibilities. Next thing I do is I look at the graph to narrow it down. So I got a graphing calculator over here somewhere. There it is. This is the Desmos graphing calculator. And you can see I've typed in x raised to the 3rd plus 10x squared minus 13x plus 22, and it's showing the graph. Now, I know this is a cubic, which means it does a little wiggling. So the end behavior of this thing, you should draw that. End behavior of a cubic with a positive leading term is up to the right and down to the left. In between, it could either just sail kind of smoothly, or it could possibly wiggle. So it could go up, down, up again. So it has one of these 2 behaviors there. So looking at the graph, I can see I'm missing stuff because this just goes down and up. So then I'm going to use the wheel on my mouse to zoom. Oh, there's more of it. And let's see, can I grab an axis to zoom here? No, I can't. Okay. So I haven't used Desmos in a while, but so there's going to be a peak up there somewhere and a valley down there, max and a min, but I really care about the zeros. And Desmos is telling me there's zeros at -11, -1, and +2. So now Desmos has done all the work for me, but I'm going to do a little more to help you guys out. So looking at the graph, I'm going to pick on, say, 1 appears, or let's see, -1 appears to be a 0. So I'm going to do a synthetic division with -1. If I do that, I'll write down the coefficients. And I'm hoping the last term in synthetic division, which is the remainder, is going to be a 0. So let's see, always bring down the leading term. -1 times 1 is -1. Gives me a 9. -1 times 9 is -9. Those add up to what? How about -22? Times -1 is +22, which gives me a 0 remainder. That tells me the remaining part here. So what does synthetic division tells me? It tells me that -1 is a 0 of this polynomial, which means x minus -1, which is x plus 1, has to be a factor. And the remaining factor is down there. It's 1x squared plus 9x minus 22. Now from here, since that's a quadratic, I could factor it. I could try to factor at least. I could use the quadratic formula. I could complete the square. I'm going to use synthetic division again since I have other guesses as to zeros. According to Desmos, 2 is a 0 also. So I should be able to use synthetic division again with 2. So I'm going to try that. So I'm just going to pick up on this line and just continue doing synthetic division. So I'm going to take 2 into this black part. Bring down the 1. 2 times 1 is 2. 9, 10, 11. 2 times 11 is 22. Negative 22 plus 22 is 0. So I get a 0 remainder again. So what has Desmos told me here? Or sorry, not Desmos. What has synthetic division told me? It tells me that 2 is a 0. So x minus 2 is a factor. And the remaining factor is 1x plus 11. And from up, so that tells me how this factor is right here. And from up above, I also know that x plus 1 is a factor. And so I believe this is the factored form of the polynomial I started with. Now there's one caution here. After doing synthetic division repeatedly, you have to check the leading coefficient. What that means, does it match? So let's see, if I were to multiply these guys, I would get x times x times x, which is going to lead with a 1x cubed. And the question is, does this lead with a 1x cubed? Sometimes you'll miss the fact that this might be a 2x cubed, but that's definitely a 1, so I'm okay. So this is definitely the factored form. Okay, so what did I use here? I used two things. I used the rational zero theorem, which tells me possible rational zeros, and it turns out 3 of them, of the 6, worked. Okay, what worked was, let's see, -1, +2, and -11. All right. Then I used the factor remainder theorem with synthetic division to actually identify those, besides just looking at the graph, which Desmos helped me check. So, oh shit, hopefully the recording's still okay. That was weird. All right, next problem. Let's do another one of these. So I pulled another one out of the practice test. The next one is f of x equals x cubed minus 4x squared plus 6x minus 4. So I want to do the same thing here. I want to use the rational zero theorem to identify possible rational zeros. Possible zeros. And the possible zeros are fractions. Now, there are zeros that aren't fractions, like the square root of 2 could be a 0, I could be a 0, but the rational zero theorem won't help me identify those. All right, so looking at this here, that is a 1x cubed, and those guys there are my denominators. So denominator of 1 is nice, I like that. -4, I ignore the negative at first, those give me possible numerators. So for the rational zeros here, denominator is 1. Numerator comes from factors of 4. Well, 1 goes into 4, 2 goes into 4, and 4 goes into 4. If you're unsure of the factors of the number, do a factor tree. Or actually, no, do a factor tree, do a factor list. That means take the number in question and say 1 goes into that 4 times. Then go to 2. 2 goes into that 2 times. Now I'm done here, but next I would check 3 and so on. And this gives me all possible factors of the number. Now these could be positive or negative. So that tells me I could have positive or negative 1, 2, or 4. Next I look at the graph on a calculator to see which are the best candidates. Once I pick a good candidate, I use synthetic division to narrow it down. So let's look at Desmos, and I've already typed this sucker in. Let's turn U off and U on. All right, and Desmos says there's a 0 somewhere between 0 and 5, and that's the only one. Interesting. What the hell does that mean? Let's zoom in. It looks like it's 2. All right. Now, a cubic can have up to 3 zeros, and actually every cubic has exactly 3 zeros. They may be repeated, or they may be imaginary or complex. So let's go and see what we got here. So we believe 2 is a candidate, so we're going to do synthetic division with 2. Into the coefficients 1, -4, +6, and -4. All right, those are the coefficients of the original polynomial. Leave myself a little space, bring down the leading 1. 1 times 2 is 2. -4 plus 2 is -2. Remember, it's always add, come down. 2 times -2 is -4. 6 plus -4 is +2. 2 times 2 is 4. And yes, the remainder is 0, just like I hoped. So that tells me that f of 2 is 0. That also tells me that x minus 2 is a factor. And the other factor is x squared minus 2x plus 2. All right. Now, I'm not going to do any more synthetic division because none of these other numbers are rational zeros, right? Plus or minus 1, plus or minus 2, plus or minus 4. Because when I look at the graph clearly does not hit at -1, or -2, or -4, or +4. So I'm done with synthetic division. All right. So we only do synthetic division if the graph shows that some of those guesses are actually zeros or candidates, because it looks pretty damn close. Nothing's close. What do I do next? Well, fortunately, we are masters of quadratics from the last chapter, so we're going to factor that sucker right there. Or we could use completing the square, or we could use the quadratic formula. I like completing the square. Most people like quadratic formula. So, if you like the quadratic formula, go for it. I'm going to complete the square. X squared minus 2x plus 2. You might ask, why the hell would I complete the square? Well, I think it's fun, and I usually complete the square in the following conditions. If that's a 1x squared there, and if the middle coefficient is even, then completing the square is usually easier than the quadratic formula. So I'm going to rewrite this as x squared minus 2x, and I'm going to subtract this 2 to the other side. Completing the square then says take your middle coefficient, -2, cut it in half. That gives me -1. Then take that -1 and square it. That gives me +1. The second number is the magic number you add to each side. It's the square. The first number, the -1, tells me what goes inside the perfect square parentheses. It means I'm going to have an x minus 1. Minus 1 here, minus 1 after the division by 2. On the other side, I get -2 plus 1 is -1. That was easy, wasn't it? Now I take the square root of both sides. Square root of -1 is, you are correct, it is I. On the other side, they cancel, provided I write a plus or minus on this side. So I get, adding 1 to the other side, x is equal to 1 plus or minus I. So my zeros are 2, 1 plus I, and 1 minus I. To put this in factored form, I write x minus 2, x minus, now I'm minusing this whole thing, so it's going to give me a -1 minus I. And then subtracting the second one, I get x minus 1, but plus I, because I have to distribute that. And this is the factored form of the original. Sometimes we don't like writing the i's as factors. I like them. I think they're cute. But if you don't like them, then the only alternative for writing this in factored form, this guy right here is what's called an irreducible quadratic. you could have written this as the factored form. And it depends on the directions. You need to be careful. Down here, what I have are called linear factors. They're linear because the highest power is an x, and x, and x. This second factor up here is not a linear factor. It's called an irreducible quadratic. Irreducible. And the irreducible part means you can't factor it using rational numbers. But I can factor it using complex numbers. All right. Let's see. So I had 2 requests for problems like that. What else? I had a request for building polynomials based on the zeros. So one of the problems I was given to solve was the zeros are 5, and that 5, oops, wrong button, have multiplicity 1, and -2 with multiplicity 2. So what does that mean? That means f of x could look like this. It's always x minus the 0, so x minus 5, x minus the 0. X minus -2 would be x plus 2. Multiplicity 2 means that occurs twice. And you could either write it like that, or you could say this is x minus 5 times x plus 2 squared. Hang on, there's an alarm going off in the other room. I'm going to check it out. All right, all's clear. All right, so sometimes on the test and the homework it says you can leave it in factored form. So if you can leave it in factored form, you're done. Boom, this is the answer. Or the next one, whichever you like. If this was on a written test, I only circle 1, not 2, just in case I screwed up on the second one. So pick the one you like best. I like this one. Alternatively, you might be asked to multiply that all out, in which case, if somebody asked me to multiply a bunch of things, I can only do 2 at a time. So I would start this by multiplying x minus 5 times x plus 2. And so distributing, I get x squared minus 5x plus 2x minus 10. Looks pretty good. Combining like terms in the middle, I get x squared minus 3x minus 10. Okay, so I'm partway done. I multiply those 2 together. Now I have to take that result right here, multiply it by x plus 2, and I'm going to do that by stacking. So underneath I'm going to write x plus 2, and I'm going to multiply. 2 times -10 gives me -20. 2 times -3x gives me -6x. And 2 times x squared gives me 2x squared. Like multiplying regular numbers, I leave a space underneath. X times -10 is -10x. This way like terms add up. X times -3x is -3x squared. And x times x squared is positive x cubed. And then I add coming down. That's going to give me x cubed. -3 plus 2 is -1x squared. -10 plus -6 is -16x. And then -20. I believe that this is the polynomial that I want, and that it has the zeros 5 and -2. If I were to graph this sucker, the end behavior should be like that, because it's a positive x cubed. And let's see, it has zeros at -2, and 5. Let's say 5 is right here. And the multiplicity 2 means it bounces off that 0. And so this thing's going to look something like that. So the x-axis would be where? Somewhere over here. Or the y-axis, sorry. So there's a very crude sketch of what this looks like. It would be a good idea to check it on my graphing calculator. So let's turn those off and type a new one. So we have x raised to the third power minus x squared minus 10x. What's the last one? I forgot. Oh, minus 16x minus 20. 16x minus 20. Isn't that cute how it graphs along the way? All right, let's drop the keyboard. Hey, look at that. Bounces off -2. Looks like it goes through 5. Desmos says yes. I could zoom out, see that it drops somewhere down there. Oh, wrong way. All right, look at that beautiful polynomial. All right, a little nicer than my sketch. That's okay. Let's do another one of these. All right, so I checked my answer. It does have the right zeros and the right multiplicity according to the graph. New page. This one's going to be even more exciting because we're going to have complex zeros. So we want to find a polynomial with the following zeros. -2 minus 4i. That's going to be fun. And multiplicity there is 1. And we're going to have -3 with multiplicity 2. All right, and we're also told, I believe, this is a 4th degree polynomial. I believe the previous example we were told it was degree 3. All right, now this is a complex root. Complex roots always come in pairs called conjugates. So if -2 minus 4i is a 0, then -2 plus 4i has to be a 0 also. Have to come that way. Multiplicity of -3 is 2, so it must occur more than once. So the factors here are always x minus the 0. So x minus, so if I subtract this 0 right here, the minus is, the subtraction will distribute through, canceling signs, so that will be x plus 2 plus 4i. So that's its factor. The next one's factor is going to be x minus 2 minus 4i. Subtracting the -3, I get x plus 3, and then I get x plus 3 again. Now, for those of you who prefer to write these two as x plus 3 squared, if you have to multiply it out, you've got to put it back in this form right here, where it's x plus 3 times x plus 3. So that can be dangerous. All right, so the hard part is multiplying these two suckers together, so let's get that out of the way. And the nice thing about multiplying conjugate pairs is that the i's always disappear. If they don't disappear, then you screwed up, or I screwed up, or somebody screwed up. So multiplying the x first, I'm going to get x squared minus 2x minus 4ix. All right, so that guy's done. Multiplying by 2, I get plus 2x minus 4 minus 8i. So that guy's done. Multiplying by 4i, I get plus 4ix minus 8i. Uh-oh, I made a mistake somewhere. Maybe not. Something didn't look right. That's okay. So 4 times -2, yeah. Oh shit, there's my mistake. Darn. When I subtract it here, I'm going to have x minus -2, so that should be a plus right there. Let's flag that sucker in red, because Gary screwed up. I made a sign error right there, which means I have a sign error anytime I multiplied by that. So right here, 1, 2, 3. Next one would be right here. 1, 2, 3, and next one would be right here. Alright, let's fix those errors. So that should be a plus, that should be a plus, and that should be a plus. Hang on one moment. Alright, back, sorry. Alright, so I think I fixed my errors. And again, I was thinking I made a mistake because the minus 8i and the minus 8i, those should have canceled. So I knew I had a sign error up above somewhere. Alright, where the hell was I? Okay, 1, 2, 3, 1, 2, 3, 1, 2, okay. So 4i finally times this is going to give me positive times a negative is a negative, 4 times 4 is 16, I times I is I squared. And here's the cool thing, well, one of the cool things here. I squared is negative 1, right? Remember, the square root of negative 1 is I. If I square both sides of this equation, I get negative 1 equals I squared. So this is really a negative 16 times negative 1, which is really a plus 16. Cool. Other stuff that's nice. The negative 4ix cancels with the positive 4ix. Bye-bye. And the negative 8i cancels with the positive 8i. Bye-bye. All the I stuff should disappear. What is left? Well, there's an x squared. Got that. Plus 2x, and another plus 2x is plus 4x. Got that. Got that. What else is not gone? Let's see, we got a 4 here. Everything else is canceled until the 16, so I get a plus 20. So I believe this is the multiplied out version of those two right there. Can I check that? Well, one way to check it would be to apply the quadratic formula to this. And if you do that, you should get that the two answers from the quadratic formula are negative 2 minus 4i and negative 2 plus 4i. And on the test, you don't have a check your answer button, so you really need to figure out ways to check yourself. So with this, the test, I would do that. But I don't want to make this video too long. All right, so I'm not done. So I did 2 of them. I need to multiply the other ones. So next thing I would do is I would multiply this quadratic times that x plus 3 there. So I'm going to do that by stacking. So I'm going to take this x plus 3 and write it underneath. And I don't need another page to finish this sucker. 3 times 20 is 60. 3 times 4x, so that's a plus. It is plus 12x. And 3 times x squared is 3x squared. Multiplying by x, scooting over, I get plus 20x plus 4x squared, and then x cubed. And bringing this all together, I get x cubed plus 7x squared plus 32x plus 60. All right, so next I have to multiply this by the last x plus 3, and I'm going to do that on another page. Let's copy that. Come on. Oh, I missed some of it. And I think I got it all that time. New page. So we just have to carefully multiply and then check after. And I did miss a little part of it. It's okay. All right, so I'm going to multiply this by x plus 3. Multiplying by 3 first, I get 3 times 60 is 180. 3 times 32 is 96x, and that's plus. 3 times 7 is 21x squared. And then I get a 3x cubed. Underneath, I slide over, multiplying by x, and I get 60x plus 32x squared plus 7x cubed plus x to the 4th. Oops. And putting all this stuff together, I get x to the 4th plus 10x cubed plus 53x squared. Hoping my arithmetic is okay along the way. 90 and 60 is 150 and 6x, and then 180. Oops, missed the 1 there. 180. I think that polynomial has the zeros that were given. So now I need to check it. So I'm going to type that into Desmos and hope I get it right. All right, so Desmos, here we go. Where'd you go, buddy? There you are. All right, turn that one off and start a new one. So x raised to the 4th. Isn't it cool how it graphs along the way? Arrow of the exponent plus 10x raised to the 3rd. Arrow out of the exponent plus 53x squared plus 156x plus 180. And voila, there she is. Ooh, check that out. Let's see, 4th degree polynomial. The leading term is positive, so both ends go up. And it has, let's see, what did it say? Zeros. -3 is a 0 with multiplicity 2, which means it bounces off the axis there. The other zeros are complex numbers which you can't see in this particular view. Complex numbers form another axis that heads out in a direction we can't see, kind of like a magnetic field. We can feel it, but we can't see it. And if I point down there, Desmos says, yeah, this sucker has a 0 called -3. That looks pretty good. So I think I did all right. Now, it's possible that I screwed up the multiplication of the two complex zeros, but if I screwed that up, it's unlikely that I would get the -3 right after, because some of these numbers would be wrong. So I am pretty sure this is correct after looking at the graph on Desmos and seeing that it does indeed have the 0, -3, and it bounces off the axis there, so the multiplicity is 2. Whew. That was fun, wasn't it? Okay, that's it for now. Catch you soon. Bye-bye.